Right. I have always wanted to get a facet, um, but I'm not willing to pay for shipping from the UK or wherever they are in Europe. And so this is like the next best thing. I don't see these hardly ever on eBay. This thing is, let's see, it's licensed under facet patents. So this is a fully legit, um, whatever, ripoff. It's a licensed ripoff. It's not even really a ripoff, but whatever. I have no idea how this thing works. I haven't taken it apart yet. I just took it out of the box. This thing comes off, which is convenient for shipping. It makes it a little easier. Uh, Hopefully, it's not jammed up. You know, this is it's an electric machine, and this cord is it's not looking great, but it's better than some of the ones I've used. This is a pinwheel machine, so instead of having all the little drums, step drums, Leibniz screws, whatever you want to call it, it's got the little input in here that's actually got pinwheels that move with the keyboard input. The only thing I've worked on that's in any way similar to this would be this Contex right here, which is another European design. It's not quite like a true pinwheel. It's got a pin matrix instead, and you know, at least it's a little more rational with this keyboard design. I mean, this makes more sense. It's a regular 10 key. I've never used a machine that has this particular number layout. At least the zeros in the middle where you'd expect it to be. But hopefully, I'll be able to use the experience I have with this to work on this. I've never worked on something that actually had real pinwheels before, so I'm kind of excited. Okay, so I think this thing is basically functional at this point. Didn't take a whole lot of time for me to get this thing running, which I'm kind of disappointed because I wanted to, you know, have to struggle with this and learn about how all these things work because I've never worked on anything like this before. But I'm going to try to go over as much as I can the issues I did have and document like the other stuff. I'm going to try to give this thing as good a cleaning as I can and disassemble it. That way I can have problems putting it back together. And then I'll have some more insights, I guess. Because there's not a lot of videos on this one. I think Brandon Smith has a great one on this model. It's a RC Allen Model 35. So he has a great video on this. You know, there's another like a couple like YouTube shorts really, but there's not I guess enough of these to where this particular model has a ton of videos. So you know, my hope with videos like this is that, you know, there's enough people out there who have had enough issues that you're able to find like, oh, I need to figure out what's going wrong with mine. And then there's like maybe my video, someone will be able to see something. I don't know. But I have removed the clearing levers here for polishing. This one, let's see, that one's got some discoloration, and then there's the little rust spots. I figured I might as well because this thing is probably going to work forever, from what I can tell. It's got this like cast aluminum block here that's everything is just is very heavy, and with those, I tend to think that they will run forever. Um, this will only clear the accumulator, so I have to. Oh, and it falls off, but you know that's okay because it didn't really matter. The accumulator. Let's see. I got to do the counter with this, which is fine. This is fine for now. Oh, let's see. I had to mount my camera. Let me get this explained. So this thing is mounted on a vise, which has like a. Sorry, it's got an anvil down here, and I've got a vise kind of connected to it right here, which you can't see because it's holding the camera. But I had to do all of that because this was the only way I could get the table to stop shaking violently in the camera shaking whenever this thing runs. So just to kind of do a couple little demos here. Let's see, I'm going to do 625 times 625. So There we go. 390625, and this thing will automatically index the whatever keyboard, the pinwheel input spinning thing of death that is very heavy, which is cool. Let's see, clear it and do all the other stuff I gotta do. There we go. So if I wanted to index to the right instead, nope, let's just add 25 times 25. I'm going to go to the right and then put it in the middle and shift this over. And now I'm going to get it to do 25 times 25. You have to be really quick with this because this thing goes at 400 RPM and you got to be able to like immediately get your hand off there. And it will also, if you have it right here, it's not going to index at all. So I can just have it do this forever. Good news is the accumulator has a carry mechanism, the same, I guess it's actually the same mechanism that the accumulator, or the counter has a carry as well as the accumulator. So you don't have to like worry about, okay, I went over. And once again, do that. I guess I'll just have it do a division real quick just for fun. The little feet I have here are not doing much for vibration dampening. So I need to probably get this thing put back together if I want to keep demonstrating a bunch of things. But put it in division, which is this side, and then this thing I guess doesn't do anything in division. What is it? 355. Shift it. Nope. Okay. Add. Come on. Add. There we go. Now I have to clear this. All right. We're going to do 113 and divide. It's doing that thing where it like goes, I guess, in one direction and then it goes in the other direction. Someone else has explained that a lot better than I have. But there we go. Got the right answer. I am definitely going to have to replace the carpet in here. This is, I'm honestly not used to carpeting like this. It's, looks like it's had seen better days, but I've got some carpet samples. I'm thinking maybe this kind of like an institutional carpet pattern would look nice in here. I might even go for more of like a shag carpet and really do like a whole 70s thing in here. I'm sure that would insulate better than what this is. I'm hoping that this is just cotton maybe and not some kind of horrible, 40s stuff that I shouldn't be touching or breathing in. All right, so this is the motor on my little motor stand. It was the camera stand earlier, but I've repurposed it. The motor is incredibly easy to remove. You've just got two little screws in here that hold it to the frame. And then, once again, my camera is not very good. There it is. Okay. So that is the switch. It's the finger that pushes down on the switch. Is probably a term for that. But that is where it turns on and off the power. So this whole thing, like in terms of the electrical assembly, just trying to remove that, this was honestly like the ideal situation. There was zero effort needed. All right, I was able to get the carpeting in here replaced. Ended up going with some cork. I feel like that was a pretty good choice. I'm not sure who the previous tenants were. Probably some rats, maybe mice, but they're not getting their deposit back. I can tell you that much. I've been trying to like completely redo the striping here from scratch because it was like 100% gone. I've just been using electrical tape. I'm gonna go back over that one, but it's not looking too bad there. That second stripe, I'm gonna try to do one more coat and see if I can get that to look even. Now, unfortunately, I have to have some bad news here. Sometimes. So let's take a minute to. This was the best I could do. This was my absolute trying as hard as I could to fix this lettering up here. But unfortunately, I'm functionally illiterate. So, like I might have had paint that matched pretty good, but this looks so bad that I'm just gonna have to get it all off. Towards the end, I was starting to make some jokes around here because I knew that this was not going to work. I think that by the time I got to this side had more lettering on it. Like this one's almost 100% the regular lettering, but by the time I got over here, there was nothing to reference it with. And my pen, the ink, whatever paint pen that was matching here is like it's very broad. Like it's not a fine tip at all. So this just ended up getting worse and worse. I mean, check out that. I don't know why I went back up with the S, but like you can't. Oh well, I'm gonna just. I might do like a pirate theme. I'm thinking like a skull and crossbones and like shiver me timbers or something, and just kind of make a joke of this at this point. But other than that, I think the show's going pretty good. I'd save some of this writing. I ended up erasing all of this writing because it was mostly gone. But gone and just a lot of scrubbing has worked pretty good for that. All right, one thing that's a little annoying about how they made this thing is the operation lever is over here. If you want to do, I guess it says multiply, but it's really just multiple add. See, we got the camera shaking because I don't have my, there it is. Anyway, this lever has an instantaneous operation, like it springs back really quick. There's a strong spring to hold it in place or bring it back up. Same thing with the division subtraction thing, but this little add lever here, not only is there a delay because it has to move some things before triggering the real operation of add, so this just like adds things on to what this does basically, but there's some delay to it. Like you press the button, it takes a second and then it does an add, and it's already kind of floppy, it's not springing back like these ones. There's a little tension spring. There's a few springs that hold this whole, linkage up. There's a few places. Right here is just a really simple, easy one. And this is the original spring back here. And I added a little one. I have my trusty parts machine right here. This piece of crap. Marchant. One thing it's good for is it's got hundreds of little springs. So I can just look around and be like, oh, that one looks like it'll work. But it's getting a little better. I might try to add an additional spring if I can't find one that's the right size, but I'm thinking that that's probably about as good as I'm going to be able to get it. Alright, so this is one of the only mechanical issues I've had with this thing at all, which is really impressive. But this is just the lower part of the right side of the machine here. And I'm going to point out, just going to shake the table a little bit, but I'm just going to do like a repeated add, repeated subtract. You've got this little lever, this thing that just like goes back and forth at 1,000,000 miles an hour, and it appears to me, at least down here, that its whole job is that, say I hold down the add lever and it's just going back and forth. When the operation finishes, it's kind of hard to see. I'm going to try to take a slow-mo video, but there's a tiny little lever that maybe if I put the camera really kind of at a better angle. I don't know what I think this is like a 24 FPS camera, so it might not work. But this little lever right here will swing outward. There's a little, maybe I can move it without shocking myself. There, so it's kind of, this thing right here will swing outwards. And when it swings outwards, and this is also back here, it will be able to push this back into the position it's at now, which will finish the operation. So let me do a repeat add, and I think you can probably see that. It's kind of flipping back. Do a repeat subtraction. So if this is unable to hit this, basically, what'll happen is this. Oh, I dropped my poker. Anyway, what will happen is this. I'm gonna push the. This is the thing that makes the motor go. Makes the motor go round. Okay, is that it? Where's the thing? It's like right here. It's there. Okay. So this will just it'll keep the let me focus it. It'll keep the contact in place, which is pushed down by this, and it will just keep doing this forever. and it's like really trying very hard to stop, but it can't. Um, and for me, the issue was, with all these things, oil tends to congregate at the bottom. So like all the grease that was all up in here kind of tends to migrate down here. And without shocking myself, I should not be using a metal poker. There are two, God, this is so dangerous. There are two little things here that hinge off of this hinge point. There's a screw. Dang, let me get a little closer. There it is. That guy. So if this is at all too greasy, if this is not tightened enough or too much, then all of the things that have to move very fast, you can see them kind of jump a little bit when the operation finishes. Then this will just keep going back and forth. In my case, I didn't have to make any adjustments there, but that's just that was a pretty simple little fix. But because this was one of the only mechanical issues I've had, I wanted to document it. All right, my camera's acting up, so I'm gonna try to get a shot of the this little finger right here real quick because I'm gonna have to talk about that in a second. So when this is pushed in this direction, it takes a lot of spring tension. It's held in place with a lot of spring tension in this direction. So clearing it for this to be held in this position or to even make it to this position requires a lot of torque, and then it just releases at the end, obviously. But I'm pointing this out because a lot of machines you can actuate by hand if you're trying to, get them to work without the motor, trying to diagnose something. Um, and this machine is interesting in the sense that like this piece right here, where the friction clutch is right to the motor, is very low resistance right now. Like there are times during an operation where this thing is just so easy to turn by hand. But one of the other times, like for instance, when that finger is being pushed under tension in that direction, this has so much torque that's required to do that you really couldn't feasibly do this by hand. I was worried that, I mean, you can, but I was worried about breaking these teeth, honestly. Like I was trying to get something in here that I could turn it with. But all that to say, there are things like that, things like this thing that has to move out of the way. This machine does not lend itself very well to running at any speed below like the design speed, which is 400 RPM. Just want to mention that again in case anyone's wondering. So if you're having issues getting this thing to cycle properly by hand, or if it's too low on the RPM, if things are not getting out of the way fast enough, just wanted to make sure that like that will happen. Like this thing's running fine for me, but if I tried to clear it by hand right now, a bunch of stuff would lock up and it would just it would take a minute to get everything back in place. So just a little PSA. All right, so kind of a multi-purpose stand I've got right here. It's like a little package scale to maybe kind of help with the vibration. It's not helping at all, as you can see with the shaking you got, but I can use it to measure the weight of this thing. So let me turn it on and see what we got. There you go, 20.15 pounds. So that's why this thing is shaking so much. All right, so I want to try to demonstrate the weird way that this thing divides by doing it by hand, which, you wouldn't have to do on this kind of machine because it's automatic, but it's different from any machine I've ever used. I mean, I guess this is how the facet machines work, but everyone else, you add a number in, and then you count how many times you subtract it, and then when you subtract too many, this will underflow, and then you add that number back in because you underflowed it, move to the next digit, and keep moving. But on this, you underflow it, and then instead of adding it back in to correct the underflow, you go to the next digit and then add until it overflows. So it's like you carry the underflow with you to the next digit and then add until it overflows, like basically correct it. So I'm going to show that pretty simply with like just let's do 144 divided by 12. Okay, and I'm going to have to turn the counter in reverse because this is how you divide on this. All right, now it's red because I painted it red. Anyway, 144 divided by 12. So I'm going to subtract once, and I'm going to subtract again, and I've underflowed it so that the 9 is there. So typically you would add it back in to keep moving, but instead this machine goes to the right and adds until it corrects the underflow. So it just went over, back to whatever, overflow, and now we're at 12. So that is how this thing divides, which is weird. I'm going to demonstrate that here because in some ways it might be faster, but other ways it doesn't seem like it's really faster or slower. It's just different. Okay, so to kind of show both extremes of how this thing could be faster and slower, I'm going to just do 191919191 divided by 1. So all that's going to do is just, basically put that number in the counter. And on most machines, it would do 1, 2, overflow, go to 9. So I'll just show that real quick. This is going to be very fast. So that only had to do, like 1 or 2 per number. But on the flip side, let me do 919191919 divided by 1. It's like, in this way I've like kind of rigged it to be the worst possible combination of numbers to where it's going to take a long time to do that. So, I mean, it's not like, I don't know, it's not really useful information, I guess, because this thing is going to be automatic doing division, but I just thought that was pretty interesting. It's what R.C. Allen would have wanted. All right, here it is in all its shiny glory. I've got working pretty good at this point. I mean, it's let's see. There we go. So to demonstrate this, I think what I'm going to do just for fun is to put this side by side with the other pinwheel pseudo whatever European design calculator I have, and I'm going to make them race. Alright, this is a little unfair because you have to manually shift this one because it only has one little digit for doing division with the counter, but go ahead and set these up. 55, 15, should be good to go. 355. Okay, what about 113? Okay, I'm going to try to make this fair. Two, 9, come on, 2, 0. Oh, 1. Okay, so that was very, very minorly off by like the 100,000ths or 10, whatever. But obviously this one ran a little bit faster. All right, now we're going to do a race between this thing approximating pi and me approximating pi by hand. Okay. Yeah, looks like you got me this time. Okay, so this last part I'm going to just kind of briefly go over the very basic how these levers work and like using these things. I'm going to link in the description a PDF form of this, which is not for, obviously, I mean, not only is it facet, but also this is not exactly the same model. There's a lot of things in here, like you don't have that. These clearings, these are for automatic clearing. You do that with levers on this, but this was just like a very, I mean, it's a pretty good manual in the sense that like most of the things on here are the same. Shortcut, multiplication, all these, this lever is the same with the little, what do we got? We also have this like kind of weirdly off-putting European like wizard guy. And he's like all over, and you're trying to like learn how to do math, and he'll just like show up, and it's like, it kind of freaks me out a little bit. Come on, where's he at? Yeah, there he is. He took his hat off, and it's just like weird. And then he gets all whatever rude and says, "Hey, you better read this manual." Whatever. But I'm gonna put that in the description, just to like really briefly, if you're like me and you don't really care about like the really complicated. Oh, how do I do whatever financial calculation? I'm just gonna do this real quick. Okay, so the only thing I really wanted to go over, like specifically in the manual here, is the shortcut multiplication, which is pretty interesting because it allows you to like do things a little faster. And I'm just going to use the example in the book here, which is 75816 times 1793. So 75816 times 1793. So I'm going to be doing it in that direction. So I'm going to start with 3. I'm going to move that over manually. And typically, 1793, you would want to put a 9 here, which would require adding that 9 times. But one thing that, I mean, the later machines will do this automatically, but it's faster to produce a 9 in this register by subtraction than addition for 9 times. So instead, I'm just going to do this once. Now we have a bunch of 9s there. And the next digit is 7, so again, it's easier to get from 9 to 7 by subtraction than addition, so I'm going to do this twice. And then the last one, that's the one thing that with this, like, you can't end on a negative because you have all these 9s here, but to produce a 1, I'm just going to do this twice. And there you go. 13, whatever that number is the answer to that, which, I mean, that's pretty cool. I never knew you could, I'm pretty sure you could do that on a standard machine as well, but just thought that was worth specifically going over. Okay, I'm going to try to go over all of just the weird kind of operations of this real quick if you're like me and you just want to know how to use one of these. But start off moving the input left and right. That button will manually move it, index it to the left. This button will index it to the right. Clearing it is obviously the little C button. Let's see, if you want to add something, that number, add. That's the counter, index that by 1. There's your answer. For subtraction, this is kind of where this machine is a little weird. There's a little lever here that says sub, and up here it says stop. So if I have this up here where it says stop, the subtraction will not clear the input, basically. So if I want to subtract 17 from that, do that. Now that's keeping it in the register like it would for trying to multiply something. If you have this in this position, then it's going to subtract, say, whatever, 84, subtract that. Then it basically treats it like an addition. And because I cleared that, now we're underflowing to 99. So I'll go over that, clearing the counter with this lever, accumulator with this lever. Pretty simple. These levers right here, this one is division, and there's a little red, kind of see that, it's red, indicator for division. These two just say X with some weird kind of symbols. So it's like down, right, and left. But what that means in combination with these, try to make this simple. In this position, if I want to, let's say, multiply something, it's going to index it to the left. Doesn't matter what this little tiny weird thing is down here. So 68 times, I guess, 7. It moves it over. So if I wanted to do a larger number, 12 times 12. 1, 2, it'll move it over automatically. And you can't change that in this position. This is like the standard position, I guess is what they call it. The middle position, I mean, this is the position where this lever matters. In this position, it can either not index at all, which is what that thing means, and then it can index it to the right if you have it in this position. So not indexing it, 68 times 35, let's say. 1, 2, 3, 4, 5. Now I'm going to have to manually move it. 1, 2, 3. Doing it this way, I can also 35 times 35. I could move this over first. Move it. There we go. Having the lever in this position while this is in the middle, and this is really only in the middle that this matters, it'll index to the right, which is, I mean, it's a little more intuitive, I guess. I prefer to multiply this way, but let's say I want to do 256 times 256. I would move this over twice, so now I'm in the hundreds position. 256. Oop. And then sometimes with this, it goes over really fast, but that's how that works. In division, this doesn't really matter. It's in division. You can't really control what this does. However, in division, do not press this button, because if you do, just like if I had divide, it would start dividing by 0. It's just going to keep going, which is, I don't think that's just, I'm pretty sure that maybe was supposed to be interlocked and they just didn't ever interlock it. So you can stop a division by pushing this in, like that, or you can just kind of bump the clear a little bit. That's what I usually do. That's why this says stop, but it's really not. I prefer to just do that. Okay, so division. This doesn't matter. You want to add something all the way to the far left first, so 625. Nope, I'm going to do something better than that. I'm going to do 1, 2, 3, 4, 5, 6, 7. That's the wrong, it's that one. All the way to the left, and then add. Every time you divide, it's going to underflow the counter, basically, because by adding in division, it's set in reverse. So you have to clear that every time you divide something. And I'm going to divide that by 79 to move it over again. That's all this button does, is just you hold that down, it releases the spring that holds this direction. Fling it all the way down there. Make sure that goes all the way to the left, and then hit this subtraction divide button here. Put all the digits in the counter. You can stop this at any time if you don't need that many digits. That's one thing with the manual mention that's, I guess, pretty useful. Oh, let's see. I don't think there's a whole lot else to just the basic using of this. I guess I might go over this. So I'm going to just put this in subtraction because it's easier. Dealing with negative numbers on this, really on any machine, but let's say, I don't know, what's something easy? 400 minus 650. Add that in, minus 650. Oh no, that's not the right number at all. But if you take into account that that's the complement of the answer, you can subtract these last digits here twice, and it will do the complement of the complement, which is your answer. So let's do, what is it, 999750. And I forgot, you do have to have that up. It's easier. Do that twice. There it is, 250. So that should be about it. If you just want to, I don't know, you have one of these things, you just want to see how to use it.